What's up, guys? I'm Chad Barnes, and welcome to the channel. Here, it's all about real car talk, from simple fixes to smart driving tips and keeping your ride in top shape. If that sounds good to you, go ahead and give the video a thumbs up. Hit that subscribe button and make sure you watch all the way through. There's a lot of good stuff coming. Let's get to it.
DPKV and DPRV. What is it? I have remembered about the crankshaft position sensor for a reason. Its task is very close to the one solved by the camshaft position sensor. And they are practically the same. So why do you need a second sensor that monitors how the camshaft rotates? There was a time when motors did without it, relying solely on the data of the crankshaft position sensor, DPKV. Everything was fine, but gasoline consumption in this case was noticeably higher due to the pair-parallel mode of fuel injection. That is, fuel injection passed through two simultaneously opened injectors. In one cylinder the fuel started to work, burn, and in the other cylinder it was wasted. In the age of total greening of engines and ecologists' rampage, such wasting of gasoline could not be tolerated, and then in addition to DPKV there was a camshaft position sensor, CPPS. The fuel injection algorithm has changed. Now only one necessary injector is opened. The era of phased injection has begun. The task of the VFD is to let the control unit know that the piston in a particular cylinder is approaching the top dead center, and now it is necessary to spray fuel through the open injector. The other injectors do not need to open. Theoretically, this sensor is not as important as the DPKV. The main functions are performed just the crankshaft position sensor. He himself is able to determine the speed of rotation of the crankshaft and its position at a moment in time, that is, to determine the phases. And the sudden failure of the camshaft position sensor is not as terrible as the failure of the DPKV. Most often, the engine will only switch to the pair-parallel mode of fuel injection, but it will not stand on its own. I will tell you more about the symptoms of DPSC failure below. But precise synchronization with a failed camshaft sensor will be impossible, and it will have to be replaced. It is not for nothing that the VFD is often called a phase sensor, although it is not quite accurate. So what is it and how to check it? Twin brother here again, the crankshaft sensor should be mentioned. Camshaft sensors are exactly the same in design. They can also be optical, magnetic, inductive, and Hall sensors. The latter are the most common, and we will talk about them below. Let me briefly remind you what the Hall effect is. There was such a scientist American uncle, whose name was Edwin Hall. He worked at Harvard and once wondered whether it was possible to somehow change the resistance of a conductor in a magnetic field. After a series of experiments, he found out that when placing conductors with direct current in magnetic fields, potential differences appear. This phenomenon was called the Hall effect, and the resulting potential difference was called the Hall voltage. The Hall effect is used very widely. For example, in electronic compasses of smartphones. But we are interested in Hall sensors that utilize this effect. These sensors react to approaching metal by changing the voltage on the signal wire. The metal that needs to be brought closer to the sensor is the same setpoint disc or a separate rail on the camshaft. In general, the system is almost the same as the same type of DPKV. Structurally, the camshaft position sensor is also not very different from the crankshaft sensor. Its main part is a coil, which after switching on the ignition receives constant voltage from the onboard network, 12 volts, actually. A little more, but for simplicity, 12. The third wire of the sensor is a signal wire. It returns to the ECU an average of 90 to 95% of the voltage. At the moment of passing the repeater near the sensor, the voltage on the signal wire drops to a value lower than half a volt, different. Cars have different values, but on average, 0.2 to 0.5 V. This is the signal to the ECU. And it is noticeably more accurate than the signal from the crankshaft position sensor, and in motors with phase shifters it is there. Only one that can accurately indicate the phases. What happens if the signal fails? Maybe it does, maybe it doesn't, and it will be simple. The ECU, using the data from the crankshaft position sensor, will know when the pistons pass the top dead center. But it won't know which piston is approaching that point. To prevent the engine from stalling, the ECU will command the injectors to switch from phased injection to pair-parallel injection. The engine will run, but not in normal mode. It is interesting that an inexperienced driver will not even always realize that there is some trouble with the DPRV, check engine. Does not always light up, and a novice, in this case, it is not a tool against spies and other liberals, but an inexperienced driver often simply does not notice the loss of traction. He may not even notice the increased gasoline consumption. In more severe situations, of course, check engine will light up. Everything is clear here. Diagnostics will show everything. In addition, there may appear quite unpleasant symptoms: uneven idle speed, jerks when gaining speed, trolling, and sometimes the engine may even stall. Starting can also be difficult. Occasionally, the symptoms of a dead DPRV are manifested only at higher revs, but this happens quite rarely. Unfortunately, all this set of troubles cannot unequivocally speak about the failure of the camshaft sensor. For example, the ignition coil or gasoline pump can die with the same symptoms. Or something else. These symptoms are very vague. But it is necessary to find the fault of the sensor somehow. Then let's look for it. Not just anyone can look. Not everyone can do it. To be honest, diagnosing this sensor isn't very easy. But let's try and do something about it. Let's start with the simplest and most obvious method: connecting a scanner. Even an inexpensive scanner such as Rocador ScanX, which despite the low price will show all the main errors of any car. And the errors can be different. P0340, no signal determinant of camshaft position. P0341, the phases of timing do not coincide with. The tax of the CKD. P0342, low level of signal in the chain DPRV. P0343, high level of signal from the DPRV. P0339, incorrect signal from the DPRV. The most common error is simply no signal. P0340. But this section is not for those who know how to use the scanner. They already know everything. So we will go our own way, the way of hammer, analysis, and cheap multimeter. Just the way we like it. So, if you don't have a scan tool, the easiest way to check the VFD is to install a known good sensor. It is usually not difficult to find it on the engine. It stands somewhere on the edge near the end of the camshaft, and it is easy to remove it. But here is the trouble. Few people have a spare VFD in the storeroom. Therefore, we think further. Another method is a little more complicated, but also quite working, with voltage measurement on the signal wire. For this purpose, it will be better to sharpen the multimeter probes to the state of needles to pierce the insulation of wires. First find the constant 12 volts that come after turning on the ignition, then look for the signal wire. To do this, look where the voltage is lower. If, for example, on the sensor go two wires with a voltage of 13.4 V, then on the signal wire will be approximately 12, 13. 4 by 0.9. If this voltage is not present, you can congratulate yourself on your victory. The sensor does not work, the job is done. If there is voltage, we look further. Now it is necessary to check whether the sensor reacts to the repeater, i.e. to a piece of iron. Remove the sensor, but do not disconnect the connector, because without constant power it will not work. Now, with the ignition on, try to excite this sensor with any piece of iron, wrench, hammer, any iron object. If during the time when you bring the iron to the end of the sensor, the voltage on the signal wire drops to 0.5 V or less, the sensor is definitely working. If not, it does not work. Most likely it doesn't work, because you need to check it more precisely with an oscilloscope, which, of course, you don't have a hand. However, the lack of voltage drop when approaching the iron indicates the malfunction of the DPRV quite accurately, and in addition, there are other ways to check the sensor with a multimeter. The most elementary one is described here. What to do and who is to blame. There are no ways to significantly extend the life of the camshaft sensor. Like any part made of iron and plastic, it has the right to natural death. So there are only minor ways. Try to keep the engine compartment clean. Dirt does not spare wiring and connectors, and everything under the hood except the sensor, in order. Unnecessary vibrations, overheating, all this harms any sensor. By the way, this is why it is better to start checking the VFD with an external inspection. If its plastic housing has burst or the wiring to it has turned green and is falling apart in your hands, there is a reason to worry. It is useless to repair the sensor. It will only have to be replaced. And don't reassure yourself that the engine somehow works without it. In this case, the engine is working in an abnormal mode, and this is of no use to it. Finally, a couple of potential reasons why even a serviceable sensor will not work. The first is if some metal dust or shavings have gotten on its end on the long-term oil drips. In this case, the signal from the sensor on the camshaft will be distorted or will not be present at all. The second cause is the reference, or setting, disc itself. If it is somehow loose on the camshaft, the clearance between it and the sensor will vary. In this case, the signal will also be lost. In conclusion, understanding the importance of the camshaft position sensor is crucial for maintaining your vehicle's performance. This small but vital component plays a significant role in ensuring your engine runs smoothly and efficiently. By regularly checking the sensor, you can prevent potential issues that could lead to costly repairs down the line. Remember, it's always better to have this essential part functioning properly than to face the consequences of neglect. Stay proactive and keep your engine in top shape. Thank you for watching, and drive safely.